Hello again. Today we're going to talk about another way in which we can solve quadratic equations, and we're going to do that by what's called factoring. Okay, factoring is can be kind of a tricky thing sometimes. What I found in the past over the years of doing this is that factoring is either something people get or something people don't get. There really isn't a lot of middle ground. But once you get it, the good news is, boom, you got it, and all is good. But it does take some practice. Okay, and so you're really going to have to tune in, try your best here, and practice these problems as we do them. And there's no real easy way to go about it. It's just practice, 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 and then suddenly it's going to click, and all will be good. So I'm really going to encourage you to follow along, maybe write some of these down as we go, and practice them. Okay. All right. So kind of just as real quick overview, we have a quadratic equation. This is the general form of a quadratic equation. And when it says to solve, we eventually want to find out the values of x that make that equation true. So that if I plug them back in here, I end up getting a 0. Okay? And what factoring basically entails, if you remember this, but this is kind of the gist of it, where we break this quadratic equation apart into two pieces. Okay? And a lot of times this was like an x and an x. Okay? We looked at the factors of the first number, x and x. We looked at the factors of the last number. Okay, and I'm just going to make this up, 5 and 2. And then we did this foiling stuff where we tried to get it to equal the middle number. Okay, and then we could put pluses and minuses in here and such to find the solutions. But that's kind of what I'm talking about when I'm talking about factoring. And you guys have done it before. It's been a while, but maybe this will get some of the cobwebs out. Okay, and before we even start here, I'm going to tell you that we're going to take a look at about 3 or 4 different kinds of factoring, ways to factor, depending upon the problem. And we're going to take a look at about 3 examples of each one. So there's going to be a lot of examples today. But each one is kind of different. Each group is different. So it's really important to try these and tune in. Okay. The first ones we're going to take a look at are what I call the regular factoring. Okay. And these ones typically have 3 terms. Okay. And have 2 solutions. And here's the first one that we're going to take a look at. I have x squared minus 8x plus 12 equals 0. Now, kind of like when we did graphing a while back, before we can start factoring, again, everything has to be moved over to one side and set equal to 0. So we have to have a 0 on one side. And the other thing with factoring is we like the x squared term to be positive. Now, right now, there's a 1 out in front. Okay? And as you know, we usually don't write the 1 there. But we want that to be positive. We'll encounter something here in a few minutes when it's negative, and what we'll do with that. Okay, but the way that this works is once I have it set up in the right form, and it's equal to 0, I break apart into my 2 parentheses. The first place your eyeballs go is to the number in front of x squared. Now right now it's a 1. And what are the factors of 1? Well, the only choices are 1 and 1. Okay, and so I would have a 1x and a 1x. And it's kind of nice when there's nothing out in front there because it's always just going to be an x and an x. But that's the first place your eyeballs go. The second place your eyes go is to the number at the end. Okay? And we need to think of the factors of 12. Now, this is where your factor sheet comes into play. At the very beginning of the Google Classroom, okay, one of the resources there was the factor sheet. And this is where it's going to be extremely helpful. We need to list the factors of 12 or know what they are. Well, there's 1 and 12, 2 and 6, and 3 and 4. Okay? We need to choose one of those pairs so that when I do my foiling, when I multiply these together, I end up getting a negative 8x. Okay? And so, I don't know, just some of this is trial and error, guess and test, and some of you might be able to see it. If you take a second to look at it there, which one of those, if I put them in there and I foil, I get a negative 8? And I think some of you can see it. It's going to be this one right here. It's going to be 2 and 6. Okay? What if I plugged a 2 in there and a 6 in there? I just randomly put them in there. Watch this. What if I tried x times 6 is 6x, 2 times x is 2x. Can I get negative 8x? And notice I didn't put any signs in there yet. Can I use the number 6 and 2 to get negative 8? Well, I sure can. What if I did a negative 6 and a negative 2? Minus 6 and minus 2 gives me negative 8. Let's go back and put the signs in. Where did the negative 6 come from? It came from right here, so it has to be a minus 6. The 2 came from right here, and it has to be a minus 2. Okay. And one thing I can always do to check my answer is that if I foil it all back together, I should get back what I started. Watch if I foil. I get x squared minus 6x minus 2x and then plus 12. And if I combine these middle terms, x squared minus 8x plus 12. I got it. Okay, so this factors into, or breaks apart into x minus 2 and x minus 6. Okay. Okay, so there's the first one. Okay, now the directions here say to solve it. Okay, so I'm not quite done. I've got it factored apart and broken into its pieces, but now I want to find out what the values of x are. And some of you maybe remember this also. But I have two things here being multiplied together to equal 0. Well, you guys know something about the multiplication property of zeros. Anything times 0 is 0. So if I have a product of two things and it equals 0, it means one of two things. It means either this stuff, x minus 2 has to be 0, or this stuff, x minus 6 has to be 0. So that's two answers again. Well, if I solve it, if I add 2, there's one answer, positive 2. And if I add 6, x equals positive 6. So there are my two solutions. If I was to graph it, it would have two x-intercepts, one at 2 and one at 6. Okay, but by factoring, we can do it a little more algebraically, so to speak, also. Now, before I go any further, there's a little bit of a shortcut that I'm going to show you guys right off the bat. And we're going to try to use this shortcut, and some of you probably remember this. Is there a way to go right from here to here and there to there? Is there a relationship between x minus 2 and the answer being positive 2, and x minus 6 and the answer being positive 6? Yeah, they're the opposite of each other. Okay, we'll see that again. Okay, so I'm hoping for is once we get it factored, going from here to here, finding the two solutions isn't going to be too terribly bad. Okay, all right, I have another one we're going to try here. How about this one? What if I had, x squared minus x minus 20 equals 0? Okay, again, things are arranged okay. Everything's on the left. The leading coefficient is positive. We like that. Okay, and I'm going to try and factor it. So again, my eyeballs go right to the first term first. Well, what times what gives me x squared? My only choices are x and x. Okay, then I go to the last number, 20. And if you look at your factor sheet, we want to try and find the factors of 20. There's 1 and 20, 2 and 10, 5 and 4. And I oftentimes like to write them up there next to it. But you can certainly just look at them on your factor sheet. Well, I need to find the pair so that when I put them in here, and again, when I FOIL, when I do my outer terms and my inner terms here, I end up with a negative 1 this time. They have to add or subtract to be a negative 1. Excuse me. Well, looking at these pairs up here, which ones add or subtract to give you negative 1? If you look carefully, I think it's the 5 and the 4. Okay. And if I FOIL here real quick, there's a 4x. There's a 5x. Can I get a negative 1x using those two numbers? We sure can. I think if I had a positive 4 and a negative 5, 4 minus 5 gives me negative 1. Let's go put the signs in afterwards. Okay, where did I get the positive 4 from? I got that from these two right here. It has to be positive. The negative 5 came from those two right there. X minus 5 and x plus 4. Okay, yep. So there are factors. Oh, and just as a real quick double check, I should always check my last ones. Negative 5 times positive 4 does equal negative 20 in my FOIL. But once I have it factored, I'm hoping, can we find our two solutions here? If it's x minus 5, the solution is positive 5. It's just the opposite. And x plus 4, the solution would be negative 4. And if I check my answers, if I plug them back in there, both of them would work. Okay, so those two were kind of the real nice ones, the regular kind of factor. And the thing that was really nice about it is there wasn't a number in front, or it was a 1. But that was just an x squared, which always made it just an x and an x. Okay, the next one I have here, this is, I think this is the trickiest one of them all here today. These next two that we're going to do, they look like this. 2x squared plus 9x minus 5 equals 0. Okay. Now again, once again, it's in the right form. Everything's all good. Okay, it's equal to 0. But if you look closely out here, this one has a little something extra out here. It's a 2. Okay, well, where does that come into play? Well, when I factor, if I look at that very first term now, it's not just x and x. It has a factor of 1 and 2 out there. So it could be a 2x and a 1x. We have to put those coefficients on it out there in front as well. When I look at the last number here, its only two factors are 1 and 5 from my factor sheet, which is nice. Okay? But again, now when I do this, I need to choose those factors, so when I put them in there, when I FOIL, I end up adding or subtracting to get a positive 9x. Now, the only choices back here are 1 and 5, but we have to be a little more strategic about where we're going to put that 1 and the 5. Okay? And just before I do that, whatever number I put here, it's going to be multiplied by 2. Because 1 and 5 itself don't give you 9. But whatever number I put back here gets times by 2. If you think about it, can we put them in there in such a way that we get a 9? And if you're not quite sure, guess and test. Maybe I'm going to try a 5 and a 1. Let's see if this works. This gives me 2x. That gives me 5x. Can 2 plus 5 get me 9? Doesn't work. Okay, so didn't do anything. That's not bad. That just means it didn't work that way. So if it doesn't work that way, let's try flipping them around. Let's put the 1 there and the 5 there. Now let's try it. This gives me 10x and 1x. Can we get positive 9x out of those? I think we can. What if I did a positive 10 and a negative 1? 10 minus 1 is 9. It works. Okay? Well, where did I get my 10 from? The 10 came from here, and it has to be positive. The 1 came from here, and it has to be negative. And there we go. Okay? So it's a little bit trickier when there's a number out in front, because we have to be a little bit more strategic about where we put the other factors at. Okay? Now what about solving it? Again, I have two things being multiplied together to be 0 here. So one of them has to be 0. It means 2x minus 1 has to be 0, or x plus 5 has to be 0. And I'm going to solve each one separately. Well, if I solve this one, that's negative 5. Now look at this one over here. What if I add 1 and then divide by 2? X is half. Okay. Now, is there a shortcut, like I mentioned on the last one? Is there a shortcut that we can do? And can we kind of eliminate this stuff, I guess? Well, look at this. There's x plus 5, and the answer was negative 5. That's just the opposite of that number again, isn't it? Look over here. 2x minus 1, and the answer was 1/2, positive 1/2. Okay, well, what if I took away this 2? Okay, then it would be positive 1. But where did the 2 go? It went down to the denominator, isn't it? So it's kind of the opposite of the last number divided by the first number. Positive 1 over 2. And I'm hoping that once we do a couple of these, okay, that we can just make that jump to the answer right there. But when in doubt, you can certainly write the little equation and solve it just like I did a minute ago. Okay? All right, I got one more of these. Okay, here we go. Okay, how about this? What if I had 3x squared plus 28x plus 32 equals 0? Now, all of these so far I've kind of had arranged properly, and again, everything's over to the left. The first term is positive. Just out of curiosity's sake, if it was negative, I'd have to divide out a negative 1. Or I could move everything to the right. We'll get to that here in a little bit. But right now, it's all good to go. Okay, so I'm going to do my 2 parentheses. My eyeballs go to the first number first. The only choices are a 1 and a 3. So it's going to be a 3x and a 1x. Oh man, now 32. If you look at your factor sheet, there's 1 and 32, 2 and 16, 4 and 8. Is that all of them, I think? I think so. Okay, so we need to pick a pair so that when I put them in here, I go here and here, I end up with 28. Oh boy. Okay, so boy, and remember, whatever number goes back here is going to get multiplied by 3, and it's a guess and test game. Oftentimes, what I do, because sometimes I don't really know where to start, I always tend to start with kind of the middle numbers, the smaller numbers. They seem to work more times than not. So the starting point, I'm going to start with 4 and 8. Okay, and I don't know, maybe I'm going to type in, maybe I'm going to do a 4 and an 8. Let's try it. This gives me 12x. And I'm always checking the outers and the inners, the outside terms and the inside terms, and 8x. Does that give me 28x that I need? 12 plus 8 doesn't. That's 20, not 28. So crap. So now what? Well, let's try flipping the 8 and the 4 the other way around. Let's try putting 4 here and 8 there. Let's see what that does. Okay? There's 21x. I'm sorry, 24x. And 4 times x is 4x. Can I get positive 28 using those two numbers? Okay, yeah, liking that. And since it's a positive 28, I think I need a positive 24 and a positive 4. Let's go back and put my signs in last here. Where did I get 24 from? 3 times 8 is 24, and that has to be positive. And the 4 has to be positive as well. Okay? Yep, so I got to factor. The hard part's over. Can we now use the little shortcut to find our two solutions? The one on the right here is the easy one. X plus 8, the opposite of that's going to be negative 8. Okay? And how about this guy on the right, or on the left, sorry. If I cover up this in front, most people are going to say negative 4. Yep, there's going to be a negative 4 there. But when I have a number in front, I divide by it. It's negative 4/3. So it's a fraction answer. Again, two solutions. Okay, so again, those are the most common ones. I think the one that when it has a number in front of the x squared, those are the hardest ones, just because we have to be more strategic and there's a little more trial and error, a little more guessing and testing, if you want to call it that, about where those numbers should go. Okay, but that's what I call the regular factoring. There's 3 terms. Most of the time we get 2 answers here. Okay, all right, the next ones here are ones that look like this. Okay, we're going to take a look at 3 of these. 9y squared plus 3y equals 0. Okay, it says factor out the GCF. And many of you guys know what GCF stands for. It stands for the greatest common factor. Okay, and what that is what's the biggest thing that goes into both of those numbers, if it has anything? And if it has something, we're going to factor that out first. Okay, and what I do is I kind of look at the numbers. Do 3 and 9 have anything in common? Is there something that goes into 3 that also goes into 9? Yeah, 3 does. So I can take out a 3, I can divide out a 3 out of both of them. And how about some y's? There's y to the second and y to the first. And what we want to do here is we want to take out as many as we can. We can only take out the same amount from both of them. And I want to take out the most I can from both of them. Well, if you think about it, this guy has 2 y's, and this guy only has 1. Okay? The most I can take away from each of them is a y. 1 y, so they both have a y in common. When I divide that out, what's left over? Well, 9 divided by 3 is a 3. I started with y squared, and I take 1 away, so there's only 1 left. Okay? And then this guy, I took out the 3, and I took out the y. I took out everything. And this is where some people make a very common mistake. They think it's 0. But I'm taking away everything. And when I take away everything, it doesn't turn to 0. It actually turns into a 1. And here's kind of an easy way to check that. It's kind of like I said before. To see if you factored correctly, if you distribute back through, should you end up with what you started with? 9y squared. And I need a 1 here so that I get a 3y. If it was a 0, it'd be 0 there. So that's why it turns into a 1. Okay? So factoring out the greatest common factor. We're just looking for what do they both have in common? What's the biggest thing they both have in common? Okay? I want to solve it again. So can I use my shortcut here again? If I cover up the 3, can you see negative 1 over 3, negative 1/3? Okay. And then how about this one now? This is another one. Whenever we have a y factored out in front, all by itself there, 0 is a solution. Think about that. What if y was 0? 3 times 0 is 0, and 0 times anything is 0. But whenever we factor a variable out in front, 0 is going to be one of the solutions. Okay? All right, I just have a couple other ones, quick ones of these. These are a little bit nicer, a little bit shorter than the previous ones. Oops. Here's number 2. Okay? How about this guy? What if I had 20x squared plus 15x equals 0? How about this guy? Okay, one of the things we always look for is to see if they have a greatest common factor. Well, I think they have something in common that we can take out of both of them. How about 20 and 15? The biggest number that goes into 20 and 15 is 5. I can take out a 5, And once again, how many x's do they have in common? I think the most I can take away from both of them is 1. Okay? And if I divide a 5 out of 20, I get 4. And I take one of the x's away, I get 1 x left over. It's the 4x. And 15 divided by 5 is 3, and there's my x out in front. Okay? And to solve it real quick, I have an x out in front, so 0 is a solution. And this one, I'm going to get the opposite of the last number. It's -3 divided by the number in front, -3/4. Okay, so that isn't so bad. Kind of nice. Okay, I already got one last one for you with this greatest common factor. And this one's a little tricky. We haven't seen this yet, but it's -12x to the 4th plus 6x cubed. Okay, now, there's a negative out in front there. We don't like negatives being the first term. Okay, but hold that thought for a second. How about just look at the numbers 12 and 6? Do they have anything in common that we can divide out? Yeah, I think the biggest number that goes into 12 and 6 is 6. Okay, but rather than factoring out a +6, I'd like this one to always be positive. What if I factored out a -6 to go with it? Okay, that's going to turn that into a positive number eventually. But before I do that, are there any x's? How many x's can I take away from both of them with x to the 4th and x to the 3rd? I think they both have 3. The most I can take away from each one is 3 of them. I'm going to take out a -6x cubed this time. Watch what happens here. -12 divided by -6 leaves me with +2. I took 3 of the x's away, so I'm only left with 1. Oops. Okay, and how about at the end back here? I took away everything. The 6 is gone, all 3 x's are gone, but I divided out a negative. It's going to turn into a -1 equals 0. Okay. Well, it doesn't matter if I have an x to the 1st, an x to the 2nd, an x to the 10th. As long as I have some x's out front out there, 0 is still a solution. Because 0 cubed is 0, and then 0 times 6 is 0. And then what about this guy right here? Are you guys catching on to the little shortcut? The opposite of the last number divided by the number in front, +1/2. Okay, so that's a greatest common factor. Look to see if there's something we can take out of each term. Okay, all right, another type of factoring is perfect squares. Okay, what's a perfect square again? Well, a perfect square, if you remember, is a number that has a nice square root. Okay, what these look like this. Okay, when we factor perfect squares, okay, we're going to do the same type of thing, but you notice there's only 2 terms. It's missing the middle term. Technically, this says x squared plus 0x minus 25 equals 0. Okay, we can treat it like that, and I can factor. If I look at my first number, the only choices for x squared are x and x. 25 has 1 and 25, or 5 and 5, and I need to get the magic number 0. Well, the only ones that are going to give me 0 there are 5 and 5. So I'm going to put a 5 in there and a 5 in there. That's 5x and 5x. How do I use 5 and 5 to get 0 if I had to put some signs on it? Yeah, I think one of them has to be positive and one of them has to be negative. How about a +5 and a -5? +5 and -5. Okay. They cancel each other out and they go away. Okay. And if I solve this, I get x equals +5 and x equals -5. Okay. And sometimes you might write it, some people write it like this, plus or minus 5. Either way is okay. Eventually we'll write it this way, but right now if you want to leave it as 2 separate ones like that, perfectly fine. Okay. Well, there's kind of a bit of a shortcut with these perfect squares as well. Okay. I'm going to leave this out for a second. What if I erase this? Do you guys see, is there a pattern between this number and what ended up in the first part of the parentheses? And this number and what ended up in the second part of the parentheses? How did I get 5 out of 25? Yeah, how about the square root of 25? How do I get x out of x squared? It's the square root of x. Yeah. Okay. Perfect squares are actually kind of nice. Okay. We're really just going to take the square root of each number. Okay. Yeah. Let me try another one here once. Okay. What if I had something that looked like, how about this one? Y squared minus 9 equals 0. there's only two terms. That's the dead giveaway that it's perfect squares. Is there's two terms and the middle term is 0. Okay. But what if I did the square root of y? The only choices for y are y squared or y and y. And how about the square root of 9 is 3 and 3. And just like on the last one, in order for the 3's to go away, one has to be plus and one has to be minus. And it doesn't matter which is which. Right? And then here I get y equals -3 and y equals +3. Okay, so we like those perfect square ones. They're pretty nice. And one other thing I want to point out here, when I start out here, it has to be subtraction between the perfect squares. Okay, and I'll show you why that is here for 1 second. What if I had y squared plus 9 equals 0? Okay, so y and y, and 3 and 3. Okay, and you might be thinking 1 is plus and 1 is minus. But watch what happens here when I FOIL. When I get to the last terms right here, what kind of a 9 is that? 3 times -3, that's -9. It says it has to be +9. Okay, so, yeah. Okay, so when we do these perfect squares, they have to be separated by subtraction. Okay, so make sure you look for that carefully as well. Okay, just have a couple other perfect square ones here. How about something like, how about this one? How about 49 n squared minus 81 equals 0? Can there be something in the front besides just a variable? Sure. Well, 49 is a nice number. It's a perfect square. The square root of 49 is 7, so I can do a 7n and a 7n. 81 is a perfect square. Its square root is 9 and 9. 1 is plus, 1 is minus. And they factor really nicely. And my two solutions again, -9/7 and +9/7. Okay, yeah, so you kind of like those perfect squares. They're pretty nice. Okay. All right, there's one last type of perfect square problem. Okay, and it looks something like this. X squared plus 8x plus 16 equals 0. Now this one has 3 terms again. So it kind of looks like those first ones we did. Let's check this out. They don't have any greatest common factors, but if I look at my first term, the only choices are x squared and x, or x and x rather. 16 has a bunch of choices, 1 and 16, 2 and 8, 4 and 4. And I need to get the magic number 8. Which one of those can give me 8? I think it's these guys right here. What if I tried a 4 and a 4? And if I put some signs in there, I think if I did +4 and +4, I get +8. Well, if you look carefully at that, well, yeah. Okay, that's really the same as x plus 4 squared. If I have 2 of them, okay, x plus 4 squared. Now, you don't necessarily have to write it as the quantity squared. Okay, it's really wanting us to solve it. So if I solved it, I get 2 nice -4 and -4. Oops. Okay, it looks like 2 answers, but it's really the same answer. So technically, there's just one answer, -4, meaning that it only has one x-intercept. Okay, but the reason this is kind of included as perfect squares is because we get the same thing twice, and we could write it as x plus 4 squared. Not that you have to, but that's the other type of perfect square problem. But most of the perfect squares that you're going to see that are dead giveaways are the ones that just have 2. I'm sorry, wrong one. Are the ones that just have 2 terms to start with, and they have nice square roots. Okay. All right, we're almost done here. Okay, last thing here, well, second to last thing, we're going to combine everything. Okay, put it all together. And I'm going to take a look at 3 little examples here. What if I had this? 4x squared minus 144 equals 0. Okay, if I could give you one suggestion on all of these, the very first thing I would look for is always try and factor out a greatest common factor if it has one. Is there something that goes into 4 and 144? Okay, and if you look at it on your factor sheet, if you look at 4 and you look at 144 on the back, what's the biggest number that's a part of both lists? If you look closely, it's going to be a 4. Okay, and if I take out a 4, I'm going to get x squared, and you get 36 left over. Okay, and once we factor out that greatest common factor, we should always look at this leftover stuff. Can it continue to be factored one more time? If you think about what we talked about a minute ago, x squared minus 36. There's only two terms. They're separated by subtraction, and they're also perfect squares. I think they have nice square roots. X squared is x and x. 36 is 6 and 6. 1 is plus and 1 is minus. What happens with this 4 then out in front? The 4 just comes along for the ride. Okay? And if I wanted to solve it, it has two solutions here. One answer would be positive 6. One answer would be negative 6. Now some of your problems today, I should clarify this, are just going to have you factor. If it said factor completely, that's all the farther you had to go right there. But if it said equal to 0 and solve, we have to go the one extra step and find the solutions. What about this guy? Is 0 a solution? No. 0 would be a solution if there was an x that went out there with it. As far as solutions goes, the 4 doesn't have anything to do with it. 4 isn't a solution either. It's only the ones with the x's in it. Okay, so there's one of them. Okay, let's try another one of these ones. How about this guy? Here's one. A second one. How about this one? Negative 3x squared minus 10x plus 8 equals 0. Okay. Now, I don't think there's a greatest common factor. There isn't something that goes into all three of them. I don't see perfect squares. None of those have nice square roots, but the thing that jumps out at me on this one is this is negative. Now, there's one of two things you can do. I can factor out a negative 1, which would make it 3x squared plus 10x minus 8. That's one option. Okay, but I'm going to throw out another one out there that I think personally is a little bit easier. Is there something else I could do that could make that 3 positive? What if I moved everything this way to the other side and put the 0 on the left? It'd become a positive 3x squared over here. I'd add 10x and then subtract 8. Personally, I like doing that. Then I don't have to worry about factoring out a negative or anything like that. Okay, now this kind of goes back to the normal one that we did at the very beginning. My only choices for 3 are 3x and 1x. 8 has a couple choices, 1 and 8 and 2 and 4, and we need to get a 10. And remember, whatever number goes back here gets multiplied by 3. Okay, and for simplicity's sake, I'm going to try 4 and 2. What if I did a 4 and a 2? I'm just going to throw them in there and check it. Oh, 12x and 2x. Can I get positive 10 out of that? I think I can. What if I had a positive 12 and a negative 2? Yep. 3 times 4 is 12, minus 2 gives me the 10. Yep. So there I got it factored. And last but not least, can we find the 2 solutions? The one on the right here, when there's just an x, remember it's the opposite. X plus 4, the solution is negative 4. How about this one on the right? The opposite of the last number, positive 2, divided by the number in front, 3, positive 2/3. Okay, so again, with that one, it had the negative out in front. I like just moving everything over to the other side. Okay? Yep, and I got one last one. Oops, shoot. Come on here. One last one with these. Okay, what if I had this one? Negative 7x plus 6 equals 20x squared. Again, things are out of order. Remember, we always want the x squared term to come first, and we want that x squared term to be positive. Well, the x squared term here is on the right, and it's positive on the right, so I'm going to keep it on the right. So with that being said, what if I move those guys over to the other side, kind of like I did a minute ago? 20x squared, I'd have to add 7x, and then subtract 6. Okay. Then I'm going to look at what I have. I have 3 terms. None of them are perfect squares. None of them have nice square roots. I don't think there's a greatest common factor I can take out of anything either. 2 goes into 6 and 2 goes into 20, but not 7. So I think I'm just stuck. And I need to think about those factors of 20. Okay? I could do 1 and 20, 2 and 10, or 5 and 4. And back here it's 1 and 6 and 3 and 2 are my only factors. Okay, well, where do you start with the 20? 1 and 20, 5 and 4, 2 and 10. Again, I start with the smaller middle numbers. I'm going to try a 5x and a 4x. And back here, I'm going to start with, I just try 3 and 2. Okay, maybe I'm going to try a 3 and a 2. Let's see if that works. I just randomly plugged them in there. There's 5, oops, not 5x, but 15x. 5 times 3 is 15. 2 times 4 is 8x. Can we get 7? Can we get a positive 7 out of that? I think so. Huh. Positive 5 and negative 8 gives me 7. Positive 15. Why do I say 5? Positive 15 minus 8. Well, where did my 15 come from? It came from right here, and I need it to be positive. My 8 came from right here. It has to be negative. There I got it. Okay. So again, I've gotten lucky here today. I've gotten most of these on the first try. But if it doesn't get the first try, flip them around. If you try 2 numbers both ways, if that doesn't work, then try the other set of factors, the other numbers. Okay. Can we find the 2 solutions? Both of these are going to be fractions. If I do the one on the left, opposite of the last number, divided by the first number. Negative 3 divided by 4. Okay. Yep, there we go, a couple fraction answers. Okay, so this factoring is kind of a, hopefully, I'm hoping that you've been doing these. The more you practice it, the easier it becomes. There's no real shortcut with factoring, but I know there's some of you guys who got this and boom, it clicked. And now you got it. Okay, all right, there's one very, very last thing. Okay, we're gonna go backwards. Okay, boom. Write a quadratic equation in standard form whose solutions are that. Okay, well, kind of what this is saying is, if I down here at the bottom, x equals 3 and x equals negative 2, we want to work our way backwards and come up with a quadratic equation where that came from. Let's think about this. If I go backwards, where did x equals 3 come from? Could that have come from x minus 3? And x minus 2 came from x plus 2. Okay? It's going backwards of what we've been doing. And then to find the quadratic equation where they came from, we're going to FOIL. X squared plus 2x. My middle terms is minus 3x minus 6. And if I combine my oh crap. Shoot. X squared, what did I have here? Shoot. Plus 2x minus 3x minus 6. If I combine my middle terms right here, I think I get x squared minus x minus 6. And that would be the quadratic equation that we're looking for. But it's just going backwards. But notice how it started down here and work our way backwards. Okay? Maybe I'll start at the bottom. If x equals 5, that came from x minus 5. X equals negative 8 came from x plus 8. And then it's a FOIL problem. I'm just going to pass x squared plus 8x minus 5x minus 40. If I combine those like terms, x squared plus 3x minus 40. There's our answer. So again, when they're integers, it's not so bad. I got one very last one. This is it. I think, yes, right here. Oh man, how about when they're fractions? So think about this. X equals 3 halves, and x equals negative 4 fifths. Let's think about, where did 3 halves come from? What if I took away the fraction? If I just said x is 3, you guys would say x minus 3. But where did that denominator come from? If you remember, we divided by the number that was in front of the x. It has to go back in front of the x. Positive 3 over 2. Whoops. Copy there. This is 4 fifths. Okay. Again, sometimes it's helpful for me. I'm going to cover up the fraction. If it says x minus 4, it comes from x plus 4. But there's a 5 underneath. 5 goes out in front. And then we FOIL it together. The hard part's over. I can get 10x squared plus 8x minus 15x minus 12. Oh, I did it again. Shoot. X squared plus 8x minus 15x minus 12. Erasers read that. If I combine those, minus 7x minus 12. So fractions aren't anything to be scared about, nervous about. Just remember the denominator. The denominator came as a multiplier up front. The denominator came from a multiplier up front. Okay. I know that got to be kind of long. There are a lot of examples, but good luck. Give it a try.